Hello everyone, today I am going to briefly talk about my previous project, learning safe value functions. So the context is we all know learning directly on hardware usually encounters a lot of failures. For example, legged robot fall to the ground and so on. And it also means is painful reset time and physical wear and tear. So the question we are gonna answer is how can we encode safety and enhance sampling efficiently during learning, while also preserving the outstanding learning outcome in the end. Let's first define the safety. Imagine we have a state space for a given dynamical system. We have a viability kernel, which also called safe set. And this set for a system, the system can always find the action that keep the system inside this set. And once the system leaves the kernel, it will lead to failure set and cannot come back. Okay, now we can formulate our problems. We consider the objective in entropy regularized reinforcement learning problems, which we take the expectation of the reward function and the entropy term along the trajectory. And then we specify the constraint function as the expectation of the indication function for the value set, which means this function will be evaluated to 1 if the state here is inside value set. So our problem becomes we want to maximize over policy for the objective function and also fulfill the constraint here. And because the constraint optimization is hard to solve in general, so we instead try to solve the penalized problems. We add the constraint on top of the objective functions. We try to iteratively solve the dual subproblems and dual problems using gradient descent because it's a Lagrangian dual problems. Before we dive into our framework, I want to record a bit of the typical procedure for solving reinforcement learning problems. So typically, we are given a new task to the reinforcement learning algorithm in which there are many interactions between agent and environment, and the algorithm try to yield the best policy out of it. But this interaction actually has too many failures, and it hampers safety in reinforcement learning. So we propose a framework for learning into two stages. In the first stage, we try to learn the task how to be safe, and then the output will be the safety information. And in the second stage, we are given a new task, and we have the safety information. We try to learn the policy safely and sampling efficiently, while also have an outstanding learning outcome. The experiment setup is that we try to compare our two-stage learning framework and the method learning from scratch. We try to answer the safety supervisor encoded with the safety information, whether it is helpful for guiding the second stage learning safely and sampling efficiently while have an outstanding learning outcome. We test our framework on the hover-shape example, but in the continuous state action space, we define the value set as hitting the ground. And you can see the learning outcome is actually nice. Our framework have a 0% of failure rate compared to learning from scratch. And you can see the blue curve, our method is learning faster and achieve similar learning outcome compared to learning from scratch. We also test our algorithm on the higher dimensional dynamical system, inverted pendulum. And in the first stage, we also define the value set. And the second stage, we achieve a much lower failure rate compared to learning from scratch. Is a really huge improvement. And you can see the blue curve, our method also learn faster, and even the learning outcome is outperforming the method learning from scratch. Thank you very much. That's my presentation.